Question 7. What an intimidating question, right? Look at this big, ugly graph here. First super important point. I can't explain to you how important this point is. I can't emphasize that enough. Every graph, every single one you've ever made in your entire life is just a relationship between two things. Every single graph is just plotting the relationship between two variables. Recently, I was talking about this in the context of, and this wasn't with you guys, this was somebody else, but I was talking about this in the context of if you had a store that sold sticks, you could say that your y-axis up here, your vertical axis, is the cost of your stick, and the horizontal axis is the length of it. And so like you as a store are saying, I want more money for longer sticks, kind of like you're buying Christmas trees. I want more money for longer sticks, and I'm going to model that in different ways. And so what I have here is a graphing calculator, and it's showing you two, let me move me over here. It's showing you two lines. One of them is this line here, 2x minus 4. And the other one is x plus 1. This red line is 2x minus 4. This blue one is x plus 1. And we recognize these simple lines here. The slope of this one is 2, and the y-intercept is negative 4. The slope of the blue one is 1, and the y-intercept is 1. Like those are the questions that we normally answer. But what we're saying is, if the x-axis is the length of the stick, how much do we pay to buy that stick based on these two models? So let's say these are like two different stores. Like my store is the red store, and Molly's store is the blue store. And if I were a customer, would I rather go to my store or Molly's store? If the stick is between 0 and 5 feet long, my store, the red one, is going to be the cheaper one. Like you want to go to my store to buy short little sticks. If the stick is more than 5 feet long, it starts to be cheaper to go to Molly's store than it is to go to my store. Every graph is a relationship between two things. So the two things here that we're looking at is the length of a stick versus the cost of a stick. And each line is like a different store that we go to. If we go back to to the question, this is 3 different stores. My store is the line, Molly's is the parabola, and Ava's is the circle here. And so if we were buying sticks, again, the y-axis is how much it costs, and the x-axis is how long the stick is. The question is asking, how many solutions does this system have? A solution to a system of equations is simply the same value for x that results in the same value of y. You want the point that has the same values of x and y. So over here, if you look at like, let's take like 2, for example, at my store. Sorry, this is Molly's store. No, this is my store. At my store, if a stick is 2 feet long, it's $0. At Molly's store, if it's 2 feet long, where are you? Right there. If it's 2 feet long, it's $3. The solution to a system of equations is the point where all of the x and y's are the same for both stores. How much? This is how long does a stick have to be to cost the same for both stores? And the reason that's like an important concept is because this is where it starts being cheaper to go to Molly's store instead of my store. So like these like intersections are important points on the graph. So going back to this one, the question is, for a solution, how many solutions exist here? At how many points are the x and y coordinates of all 3 lines exactly the same? This is a super easy question if you look at it from that perspective. How many points on the graph do all 3 lines overlap? There's 1 here. There's 1 here. This point here doesn't have the straight line. This point here doesn't have the circle. This point here doesn't have the straight line. Do we have any other intersections? I don't think so. I think we hit all of them. There's only 2 points where all 3 of these lines intersect. So it should be 2. We have 2 solutions to this system of equations here. And as we've been doing, let's go down and check to see if we missed anything through that explanation. First, clear this. There's not always only one solution. There's not the same number of solutions as there are equations. And it's not where any 2 places intersect. It's where all of them intersect. So it's just these 2 here.